Hey everyone, welcome back to Maestro Math Vortex Spy, where we make math fun and easy. In this episode, we're diving into multiplying and dividing positive and negative fractions because numbers don't always play nice, but we can still make them work for us. We'll explore how these fractions come to life in real world scenarios. For example, like calculating distances between planets in astronomy, tuning musical frequencies in music theory, and even figuring out voting percentages in elections. So, I would invite everyone, grab your notebooks and let's break it down together. All right, let's begin with multiplication or multiplying um, positive and negative fraction. Okay, so we have here three examples and we're going to answer it together. All right, so let's start with number one. All right, so we have here, okay, let's prepare a pen first. All right, oh, there you go. There you go. There's our pen. All right, so we have here for number one, 3/4 times 5/7 or 3/4 times 5/7. So when we are multiplying a fraction, we must remember certain steps, of course. Of course, the first step that we should remember is that when we multiply the numerators, uh, that's the first step, of course, to multiply the numerators or multiply the top numbers. So let's begin to write for number one. So we have 3/4 times 5/7. All right. So we're going to multiply our numerators, which is 3 and 5, or the top numbers. Yes, the top numbers of the fraction together. So 3 times 5. All right, that's good. And then step two is we multiply the denominators. Of course, that is 4 times 7. Okay, multiply the denominators or the bottom numbers of the fraction together. All right. All right, so what is 3 times 5? Of course, that is 15 over what is 4 times 7? That would be 28. All right, now, so that is now our answer. But we must not forget to simplify. Of course, when we say simplify, that means if we can still reduce the resulting fraction to its simplest form. And how will we do that? Of course, that is where the greatest common factor would come in, or the GCF. Now, what is the GCF? Of course, the GCF is actually the greatest common factor. It is actually used to simplify fractions. Yes, it is indeed used to simplify fractions by dividing both the numerator and the denominator by their GCF, or greatest common factor, resulting in a fraction in its simplest form. Okay, so we must be able to express our resulting fraction to its simplest form. Now, how do we get, of course, the greatest common factor of 15 and 28? Of course, that is where prime factorization would come in. I believe that we are still familiar on how to get the greatest common factor. Okay, so this is just like a review to us. Okay, so we will be using the what we call prime factorization. Let me write that one. Prime factorization, and this is actually fun and easy. Factorization. Yes. Okay. Now, so that means I'm gonna get I'm gonna get, hold on. I'm gonna get, of course, 28 and 15, or 15 or 28. Okay. In this case, we'll see if they have a greatest common factor. Okay. 15 and 28. Okay. So we have to list down all the factors of each number. And then we have also, remember, disregard the sign. Okay. That is if we have a sign. But in this case, both of them are actually positive. Okay. So let us try to get, or to list down the factors of both numbers. So for 28, we have actually 7, okay, times 2 times 2. Yes. So we have 7 to 2, right? Because 7 times 2 is 14, and then 14 times 2 is 28. How about for 15? For 15, I would put it here. So we have 5 times 3. So as you can see, there is no a common factor between 28 and 15, or 15 and 28. So that means to say that this will be our final answer. Okay, so it cannot be expressed in its simplest form, because there is no greatest common factor, or common factor between 15 and 28. And we're able to see that because we actually used prime factorization. All right. So this is now our answer. So our answer would be 15 over 28. Okay. So that is how we actually simplify our resulting fraction to its simplest form. We have to use the greatest common factor. And the greatest common factor, let me repeat, is actually used to simplify fractions by dividing both numerator and denominator, of course, by the greatest common factor. Okay? All right. And how will we do that? We need to use prime factorization, okay, by actually um, listing all the factors of 28 and 15. And then we will spot on, or we'll have to look if there is a common factor between the two. Yeah, between 28 and 15. All right. So I hope that's clear with us. All right, let's erase that one in order for us to proceed to example number 2. So for example number 2, we have negative 7 ninths, okay, times 4 6. Okay. All right. So the same process as number 1. Okay, what we have to do is just multiply our top numbers together. So we have negative 7 times 4 over, and then we also need to multiply our bottom numbers together, or our denominators, 9 times 6. Now, bear in mind, when it comes to the sign, okay, we should not be confused with the sign, just like our discussion in the video lesson about multiplication and dividing integers. Bear in mind that whenever we multiply a negative sign to a positive sign, sorry about that, then that will be negative. All right. So negative times positive is negative. All right. If you still remember the Dorito man, of course. Okay. So what is negative 7 times 4? That would be negative 28. Over what is 9 times 6? Uh, Repeat, negative 7 times 4 is negative 28. And then 9 times 6, which is our denominator, would be 54. Now, let us figure out if 28 and 54. I said 28 because I already disregarded the sign, because we're about to get the greatest common factor between the two of them, the numerator, of course, and the denominator. All right. So let us figure out by prime factorization, um, in order for us to get our greatest common factor, let us see if they have a common factor. So 28 and 54. All right, so let us list down the factors of each number. Let us list down the factors of each number. So, of course, for 28, we have 7 times 2, okay, times 2. Okay, because 7 times 2 is 14, 14 times 2 is 28. And then that's how I usually do it. All right, so that's my own strategy. And then I'm going to put 2 here because 2 times 3 times 3 times 3. Okay. Why? Because 2 times 3 is 6. And then 3 times 3 is 9, which if we multiply 6 times 9, that's 54, of course. Now, I can basically see that the common factor between 28 and 54 is actually 2. Okay. So that is actually your greatest common factor. Yes. Okay. That means that is what I'm going to use, or we're going to use, in order to simplify negative 28 over 54. All right, let's do it now. So negative 28 divided by 2 over 54 divided by 2. So the answer would be, um, sorry about that. So negative 28 divided by 2 will give us negative 14. Yes, that's negative 28 divided by 2. The answer is negative 14. And then 54 divided by 2, that would give us 27. Yes. So the simplest form of our answer is negative 14 over 27. All right. Okay. Easy, right? But I want to teach you another way for us to be able to get our answer, which is negative 14 over 27. Okay. So easy, right? Okay. Let's erase this one. Okay. So you can actually use this another strategy if you have spot the second fraction. You can actually reduce it. Okay, so we have negative 7/9 times 4/6. Okay, you can actually reduce this. Okay, let's try to get the common factor between 4 and 6. So we have here 2 times 2. Yes, and then we have also 2 here times 3. So again, the common factor between 4 and 6 is actually 2. So you can actually simplify them. So 4 over 6. You can divide them, both your numerator and denominator, by 2. So you'll have 4 divided by 2 is 2. 6 divided by 2 is 3. All right. So we're just showing the different approach on how to get our answer, which is negative 14 over 27. So negative 7 times 2 over, yes, negative 7 times 2 over 9 times 3. So we'll now have negative 7 times 2 is negative 14 over, what is 9 times 3? It's 27. So still the answer would be negative 14 over 27. All right. So we're done with example one and example two. That is for multiplication or multiplying positive and negative fractions. Okay. Let's move on to number three. Okay. So for number three, excuse me, Number 3, we have negative 5 halves times negative 8 over 10. All right. So we have negative 5 halves times negative 8 tenths. Okay. All right. So, or negative 8 over 10. All right. So, again, the same process. But if we noticed, we have negative times negative. So remember when we had our discussion with the Dorito man? Yeah. So negative times negative would give us a positive. Okay. So let's solve this one now. Negative 5 times negative 8 over 2 times 10. All right. So that would be negative 5 times negative 8 would be 40 over what is 2 times 10? That would be 20. And of course, 40 divided by 20 would give us our final answer, which is 2. All right? So easy, right? So whenever we're multiplying, um, what do you call this? Positive and negative fraction, I would just want to give emphasis to that. First, you need to multiply the numerator or the top numbers of the fraction together. And then second, multiply the denominators or the bottom numbers of the fraction together. And then simplify. That means if you can reduce the resulting fraction to its simplest form. And how will you do that? You will do that, of course, by, of course, finding the GCF or um, the greatest common factor, not denominator, the greatest common factor. Yes. And of course, how will you also do that? Of course, you will do that by means of prime factorization, where you have to list down all the prime factors of both numbers. And then you'll have to find there what is both, what factor is actually both in these two numbers. So when you're able to find that, yes, that's correct. When you're able to find the common factor between two numbers, which is both in these two numbers, then that is your greatest common factor. I repeat. So you do that, you're able to find the greatest common factor or the GCF by means of prime factorization. And prime factorization is actually listing down the prime factors of those two numbers. Like for example, a while ago we have 28 and 54. So you have to list down all their prime factors, and you will be able to really spot the factors that is both common to each one of them. And therefore, that is your greatest common factor. All right. So we're done with example 1, 2, and 3. All right. So I hope it's easy for us to understand. It's really easy to multiply positive and negative fraction. All right, let's move on. All right, let's move on to the next one. All right, this time we move on to dividing or division of positive and negative fraction. Okay. Now, in dividing, what do you call this? In dividing um, fractions, whether they are positive or negative, there are also steps, the same as in multiplying or multiplication of positive and negative fractions. Okay, let's have that as we solve, of course, the given examples, which is number four and number five. Okay, so let's start with number four. So we have negative 9/8, okay, divided by negative 3/4. Okay, I would repeat that because I might say it in a wrong way. So let's have negative 9/8 divided by negative 3/4. All right. Now, okay, the step here is, it's very easy to divide. Of course, there is actually an acronym for this. If you are a lover of acronym, you would be able to easily solve this problem. Yes. Of course, the acronym is actually called as KCFM. So what does it mean? So it's actually keep the first fraction, okay, that is negative 9/8, and then changed. The second step is change division sign to multiplication sign. And then, of course, F means flip. When we say flip, that means to find the reciprocal of negative 3/4, which will be, um, what do you call this? Which will be negative 4/3. Okay. Yes. Okay. And then multiply the two fraction as usual. Okay. So let's do it. So let's have, of course, the first in our acronym, which is K, keep. So that means we will not change anything with negative 9/8. Okay, and then the second step is to change the division sign into multiplication sign. And then we will flip, meaning we will have to change the position of negative 3 and 4. So it will become negative 4/3. Okay, yeah. Now there's a question here. Um, we really need to be we really need to clarify everything. So I just want to clarify one question that you might ask um, with yourself as you're watching this video. So for some, and they would say that the negative sign should be with the negative sign in 4/3 should be with negative 3. Now, while a negative sign in a fraction can appear in the numerator, yes, or actually in front of the entire fraction or in the denominator, it is mathematically equivalent to have it in the numerator, okay, or in front of the fraction. So that's why I put there the negative sign. Yes, okay. However, mathematicians often prefer to place the negative sign in the numerator. So even the mathematicians would want the negative sign in the numerator, or actually in front. So that's why I put it in front. The negative side, the negative, not side, sign. Sorry, the negative sign in front of 4/3. Okay, of the fraction. Why? That is for clarity and consistency. And just to add, when we place the negative sign in the denominator, it can actually sometimes lead to confusion. Why? As it might be misinterpreted as a negative denominator instead of a negative fraction. So that's the reason why we don't want to put the negative sign uh, in 4/3, the negative sign with 3. Okay. All right. So, yeah, at least we clarified that already. Okay. Now let's proceed. So, another thing is, I repeat, when we're multiplying two negatives, that would be positive, right? Okay. So, negative 9 times negative 4 over 8 times 3. So that will now become excuse me, negative 9 times negative 4 would be 36 over 8 times 3. That would be 24. Yes, okay. Now, very obviously, we can actually reduce 36 over 24. And by prime factorization, because we're now going to find the greatest common factor between the two of them, which is 36 and 24. So 36, 24. Okay, let us list down the factors of both numbers. So for 36, we have, okay, 3 times 3 times 2 times 2. All right, and then for 24, 24 we have, hold on, we have 3 times 2, okay, times 2. Yeah, because 3 times 3, 9. Yes, and then excuse me, 9 times 2 is 18, and then 18 times 2 is actually 36. Yes. Yeah, that's true. Yes. Okay. And then 3 times 2 is 6, and then 6 times 2 is actually 24. Oh, we're missing another 2 here. Yes, sorry about that. Yeah, 3 times 2 is 12, and then 12 times 2, yes, is actually 24. Yes, let's see. 3 times 2 is 6. And then times 2, yes, is actually 12. Yes. Yeah, we're missing 1, 2. Yes, we're missing. Yeah, yeah. Yes. Let's check it. Okay. All right. So, see, it's just easy. It's just easy, actually. I'm telling you. To Yes. Yeah. Okay. That's why we were missing 1, 2 over here. So 3 times 2 is 6. 6 times 2 is 12. And then 12 times 2 is 24. Now, let's see what is common to them. So I can see that they both have 3. They both have 3. All right. Okay. They both have 3. They both have 2. And they both have 2 also. So therefore, if I'm going to multiply all of these, so 3 times 2, 3 times 2 is 6 times 2 is 12. Yes. So that means to say that our GCF, we don't have enough space already. Our GCF for this one is actually 12. Yes. Okay. Yeah. All right. So we can now divide 36 over 24. We're going to divide that. 36 over 24. We're going to divide both the numerator and denominator by 12. Yes. So 36, 36, I'm sorry. Yeah. 36 divided by 12 would give us 3. Yes. And 24 divided by 12 would give us 2. So our final answer would be 3 halves. All right. Easy, right? Yes. So it's easy. Okay. All right. So just always remember that acronym which we just learned. And the acronym is actually, it's, let me write it here, KCFM. So that means keep the first fraction the same, don't touch it, and then change the division sign to multiplication, just like what we did here. Okay, and then flip. Okay, you're gonna flip negative 3/4 into, excuse me, you're gonna flip, excuse me about that. We're gonna flip a negative 3/4 into negative 4/3. Yes. And then we multiply. And then, of course, we simplify. Yes. And then, you find, of course, the greatest common factor by means of prime factorization. So our answer here is 3 halves. Okay. All right. That's it. All right. So we're done with number 4. Let us now go to number 5. Hold on, let's erase it. Okay, it's clean again. All right, so let's go to number 5. All right, so we have negative 7 over 12. Sorry about that. Divided by 5 over 4. So negative 7, 12s divided by 5/4. 5/4. Yes, okay, or 5 over 4. All right. So by following, of course, K, C, M. Oh, sorry. Is it M? No, it's KCF. Yes. Yes, KC. We'll put here F. Yes, okay. Because that means flip. Okay, KCFM. Yes, okay. So the first step is we're not going to touch anything with our first fraction. So that stay as it is. Be that as it may, as they say. So negative 7/12. Okay, and then we change, of course, division into multiplication. Okay, and then we flip 5/4 into 4/5. You see, it's easy, right? Okay, and then we now multiply. So negative 7 times 4 over 12 times 5. So negative 7 times 4 is actually negative 28, because negative times positive, as I said a while ago, if you're paying attention, negative times positive is negative. All right, over, excuse me, negative 28 over what is 12 times 5. Okay, yes, 12 times 5. So 0, 1. Okay, so that would be actually 60. All right. Now, again, we can actually reduce or simplify negative 28 over 60. Okay, let's clean our board. We don't have enough space. All right, so we have now negative 28 over 60. Yes, all right. Okay. So, of course, we start getting the greatest common factor. Okay, so by listing the factors of 28 and 60, that's what we call prime factorization. So here, in order for us to see the common factor to both numbers, okay, so we have 7 times 2 times 2, and then for 60, um, okay, for 60, all right, we will have 2 times 2 times 3, okay, times 5. Why is this like that? Okay, because 2 times 2 is 4, 4 times 3 is 12, and then 12 times 5 is 60. Yes. So I can see already what is common to them. Okay. Okay, so they both have 2 times 2. So that will now become 4. So therefore, the greatest common factor is actually 4. All right. So let's both divide negative 28 and 60 by 4, because that's their greatest common factor. So this will now become, so negative 28 divided by 4, negative 28 divided by 4 will give us negative 7. Yes, remember, negative divided by positive is negative. Over, so 60 divided by 4 would give us 15. Yes, that's correct. So 15 times 4, 15 times 4. Let me just check. So 15, oh, sorry, that's not the right place. 15 times 4, okay, 5 times 4, 22, 4, 5, 60. Yes, okay. So our final answer, okay, the simplest form would be negative 7 7/15ths, or negative 7 over 15. All right. So see, so we're done with number 4 and number 5. Okay. So we both finished multiplying and dividing positive and negative fraction. So always remember, whenever we are dividing positive and negative fraction, always remember the KCFM. What is that? That means that it means it means what? Keep the first fraction, okay? Keep the first fraction, and then change the division into multiplication, and then that's C, and then F means find the reciprocal or flip. Okay, that means actually finding the reciprocal of your second fraction and then multiply the two fraction as usual. And then, of course, if you must find out if your resulting fraction can actually be expressed in simplest form by, of course, finding. How will you do that? You must find, of course, the greatest common factor between the numerator and denominator. And how will you do that too? Of course, you will use prime factorization, which means you're going to list down the prime factors of both your numerator and denominator. And then you have to see and spot on what is common to both of them. Then that is your GCF or greatest common factor. All right. I hope we learn a lot from today's episode. Okay. So let us erase this one. All right. All righty. All right. Let's move on. All right. So this time we're going to be able to apply uh, our lesson for today, which is about multiplying. Multiplying, excuse me. I'm having a cough today. I'm so sorry, my friends. Okay. We're now going to apply what we have learned from multiplying and dividing positive and negative fraction into real life scenarios or into other areas, of course. So we have the first problem or word problem number one is about planets. But before that, I would like to acknowledge, of course, the source of the picture because I actually just borrowed that, with their permission, of course. The image is, um, of course, hold on. Oh, you see, I'm having a bad cough today. All right. So I would just like to acknowledge, of course, the image is actually taken, which I really took from Pixabay. And because Pixabay is actually free for use, the image was taken from Wickle Mages. Thank you very much, sir. I would like to acknowledge you, sir, ma'am, Wickle Mages, for your image of the, solar system, of course, free for use under Pixabay content, acknowledging that this is actually originally from Wickle Mages, free for use under Pixabay content. Okay, now let us read um, our problem, of course, about astronomy. Okay, so when you say astronomy, these are the study of celestial bodies, right? So a scientist, okay, let's read. So a scientist is studying the distance between planets, okay, and the distance from Earth. Okay, let's put a line to that. The distance from Earth to Mars is approximately three-fifths of the distance from Earth to Jupiter. Now, if the distance from Earth to Jupiter is 120 million kilometers, how far is Earth from Mars? Okay, so that's the first question that we need to answer. How far is Earth from Mars? And then the second question is, later the scientist discovers that the distance from Earth to Saturn is negative one fourth of the distance from Earth to Mars. Now, if the distance to Mars is found to be three-fifths of the distance to Jupiter, what is the distance from Earth to Saturn? Right. So this is a very interesting problem, which is actually related to science. So math and science together. Okay. All right. So let us solve the problem. Of course, uh, our step one is, of course, to take note the distance, to calculate the distance from Earth to Mars. So I'm going to write here distance from Earth to Mars. Okay, so that is the first thing that we need to calculate, the distance from Earth to Mars. Now, that is actually equal to 3/5 of 120. Okay, 3/5 of 120. Okay, if we're going to solve that, so what is 3 times 120? So that would be, okay, so 120 times 3. All right, let's multiply 0, 6, and 3. Okay, all right, so that would be, sorry, 360 divided by 5. And what is 360 divided by 5? So it will basically give us an answer of 72. Now, so the answer would be 72 million kilometers. All right. Now, so the question now uh, is answered of, how far is Earth to Mars, or the distance from Earth to Mars is actually 72 million kilometers. Yes. Okay. So we answered the first question. Okay. The distance from Earth to Mars. All right. Now, how about the second one? Okay. So we have actually the second question, of course. Okay. Let's proceed to the next page. All right. So the second question now is we must now calculate the distance from Earth to Saturn. Okay, let's write that down. The distance the distance from Earth, that's our planet, from Earth to Saturn. This is very interesting. All right, now based from the given that we have, okay, so the distance from Earth to Saturn is actually equal to negative one fourth, or negative one fourths of the distance that we got. Okay, the distance from Earth to Mars, which is actually 72. So that would be now, okay, so negative 1 times 72 is negative 72 divided by 4. Okay, so that would now be equal to negative 72 divided by 4. Excuse me, negative 72 divided by 4 would give us negative 18. So that is actually negative 18 million kilometers. Okay. Yes. Okay. So we were now able to get, or to answer the second answer, and that is actually the distance from Earth to Saturn. And mathematically, it shows us that the distance is actually negative 18 million kilometers. So that's the distance from Earth to Saturn, which is negative 18 million kilometers. Now, okay, there's an interesting debate in this problem here that we're going to discuss, of course, after a while. So let us just put them as one. Okay, so let's put them here. So Earth, Earth. Okay, okay, the distance. Since we're talking about distances, okay, distances Earth. Okay, so a while ago we have um distance, yes, distance from Earth to Mars. Okay, Earth to Mars is actually 72 million kilometers. That's very far. Okay, yeah, that is, again, I would repeat, that is actually the distance from Earth to Mars, 72 million kilometers. Okay, and then the distance from Earth to Saturn, okay, Saturn, okay, is actually negative 18 million kilometers. Kilometers. There you go. Now, okay, as I told you a while ago that there seems something wrong in this problem. Of course, now I will be asking you that question. The question is, it's all about this, right? Negative 18 million kilometers. My question is, can the distance between Earth and Saturn be negative? Yes, this is very interesting. Now, basically, the answer is no. Now, why is it no? Because the distance between Earth and Saturn cannot be negative. Okay, it cannot be negative. Okay, so we'll explain further. Cannot be negative. Okay, why? Because when we're talking about distance, it's actually the measure of space between 2 points. And that 2 points is actually Earth and Saturn, and is always a non negative quantity. Now, in the context of physical measurement, a negative distance, I repeat, a negative distance does not have a practical meaning. Now, if the calculation results in a negative value when measuring distances, it typically indicates an error. Is there an error? We'll find out, okay? There's a good discussion in interpretation, or that the context needs to be re examined. Now, in this case, to cut the long explanation short, it means that, for example, if a measurement involves negative fractions, because our topic is about positive and negative fractions, multiplying and dividing them, it may represent a direction, okay, a direction, or a theoretical concept rather than the actual distance. Okay, so meaning to say, the answer negative 18 negative 18 million kilometers is actually mathematically correct when we solve it, but scientifically, it is not valid, since when we're talking about distance, it should not be negative. It should not be negative. It should always be positive. You see, so that is where math and science would clash together. You know what I mean? Yes. Okay. So I hope you were interested with that discussion about math, um, which is about multiplying and dividing positive and negative fractions. And then, of course, a certain area or branch in science, which is astronomy. All right. Okay. So let us erase this, and let's proceed to the next problem. Okay. The next problem is actually very interesting too. So the next problem is about music theory. Yes, let's try to write this one. Music theory. Wow. All right. So again, I would like to uh, acknowledge, of course, the source of the image about musical notes. I have taken that, of course, from um, uh, Alexis Photos, free for use under Pixabay content license. So yes, it's just necessary to acknowledge and not claim it for myself, but to acknowledge, of course, the source of my photo, which is Alexis Photos, free for use under Pixabay content license. So I actually took those two photos in Pixabay. All right, so let us read, of course, the problem. So, okay, a music composer, wow, is analyzing the rhythm of a piece she's working on. Okay, oh, so she discovers that a particular section of the music is negative 3/8 of a measure too long due to a mistake in the notations. To correct this, she decides to divide this excess length equally among three different sections of the piece. Now, our question here is, let's encircle that. Okay, so the question is, how much length will each section need to be adjusted by to correct the mistake? All right, so since we read the problem, it's very easy for us now to solve this problem about music theory, about notes. All right, so what we're going to do is it's very clear in the problem that our step one is to divide. Okay, to divide. Okay, oh sorry, let me erase that. It's not E, it's just supposed to be I. Sorry. So the first step is for us to divide. Okay, the negative fraction. Okay, the negative fraction by the number of sections, by the number of sections. Okay, of sections. Yeah, it's obviously clear in the problem. Okay, now, so what we're gonna do now is, okay, so of course we know that the adjustment per section, adjustment, adjustment on the musical piece, adjustment per section is equal to negative 3/8 divided by 3. Okay. Now, why do we say divide? How were we able to say that the operation is what do you call this? The operation is division, because it's very clear here that to correct this, she decides to divide. Yes. So we have the keyword divide this excess length equally among three different sections of the piece, or if that's a musical piece, of course. All right. So we now have negative 3/8 divided by 3. All right. So let's try to have some space over here. So we have negative 3/8, or negative 3 over 8 divided by 3. So we know the rule here. Keep, okay, that means I'm not going to do anything to 3/8. And then I'm going to change division to multiplication. And then, of course, flip. Okay, remember this 3 has actually an unseen denominator, which is 1. Yes, I would like to term that unseen denominator, which is 1. So you're going to flip that and it will become 1/3. All right, now let's multiply. So negative 3 times 1 is negative 3 over what is 8 times 3, that's 24. All right, so we can actually reduce or simplify negative 3 24ths, negative 3 or negative 3 over 24 by, of course, finding our greatest common factor. So in this case, what is our greatest common factor? 3, 24. So the factors are, of course, 1 times 3, and then 3 times 2 times 2 times 2. Yes, the common between 3 and 24 common factor is 3. So I can now, excuse me, I can now actually divide both negative 3, which is the numerator, negative 3, divide that to 3 over 24, divide that by 3. Now, of course, 3 is actually the greatest common factor. So this will now be negative 3 divided by 3 is negative 1 over what is 24 divided by 3? That would be 8. So the final answer would be negative 1/8. Okay, so that means that, yes. So, okay, so each section needs to be adjusted by what fraction? By negative 1/8 of a measure to correct the mistake in the musical piece. All right. So I hope we were able to learn a lot from our discussion for this episode on multiplying and dividing positive and negative fractions. All right. And this time, it's time for you to solve. We have the multiplication exercises for you to solve. If you want to pause the video so that you can actually come back with some concepts to help you understand it better, you can pause it and of course take note. Okay, we have the multiplication exercises over here. Yes, okay, and then the division exercises on the right side. Left side is the multiplication, and then of course we have a real life scenario involving multiplication and division of positive and negative fraction. And it's actually referring to an election day. Again, before we end, I'd like to acknowledge again Muhammad Hassan. This picture of the process of election is actually from him, and I would acknowledge the sole owner of this image. I do not take credit to the tree image that I just borrowed. Yes, and of course I acknowledge them. Of course, that is free for use under Pixabay content license. Again, thank you for watching this episode of my channel, Maestro Math Vortex Spy. Until next math exciting episode. Yes, and have a nice day, have a nice evening, whatever time you are, and God bless and keep safe. Bye.